My name's Keith. I think you're probably all getting to know me a little bit by now, which is exciting. And I'll obviously be your host today. Look, before we crack into the meat of the fireside chat, I'd like to start off by acknowledging the traditional owners of our lands from which we're all zooming in from today. I would also like to pay my respects to elders past and present and recognise the rich history of innovative practice, which has happened for thousands of years right across this continent and beyond as well. So a little bit of admin before we crack on into it. If you'd like to ask a question, please jump into the Q&A thread below. We'll try to get to as many of your queries as possible within the hour and get Kelvin's expertise in those questions. Our Fireside and Q&A sessions are recorded and posted on our site and our socials as well for future reference. So if you'd like to access that recording, or if you're just in the F&Q region, are interested in our future events and have a broad interest in innovation and entrepreneurship, make sure you check out the JCU Ideas Lab site and register for all our updates. Louise will pop those links in the chat below. And finally, don't forget to follow JCU Connect on Facebook and LinkedIn. Those links will also be posted down below. So without further ado, I'd like to welcome Kelvin Ross. So Kelvin has over 30 years experience in software engineering and enterprise IT applications. Kelvin started his IT career in defence and completed a PhD in safety critical systems engineering. He's worked in the commercial centre for the past 20 years, so has a wealth of experience across many domains. He's the director or a director of the Queensland AI Hub, also director of IntelliHQ, which is a non-profit organisation developing the ecosystem of AI innovation in healthcare. Also the founder and non-executive chairman of KJR, a specialist IT advisory firm. And that firm has over 100 staff spread between Brisbane, Sydney, Melbourne and Canberra. He's an adjunct associate professor at the Institute for Intelligent and Integrated Systems at Griffith University. Also the director of Alchemy, an organizer of young women leaders in AI program, and has held several roles in national technical working groups right across Australia. Kelvin, it's a great pleasure to have you with us today. How are you?
I'm great, thanks. Yeah, Keith, great to be with you, and yeah, love far north Queensland. It's one of my fondest parts of the world.
Yeah, it's and look, the weather's turned it on today. I'm looking at the glass, and there's all I can see is blue sky and a beautiful day. So I wish I was playing out there today. But also happy to be here talking to you. And look, what a wonderful resume you have and a wonderful background. I would love to start, if we could, for a chat about AI and data science, with just speaking about it a bit in the general sense. I think sometimes it's seen as a bit of a dark art. So, I'd love to hear your take on what AI data science actually is and how it touches our lives every day.
Yeah, it's a good place to start. So with the AI Hub, a lot of our work is sort of informing where AI is at and what is AI. That's a really broad question as well. But to start answering that, I see AI as just this set of tools that are available now. And it's really implementation ready tools in computer vision, language, and so on. But at the heart of AI, I think what us as an industry see as AI at the moment is around what's this called deep learning. That's been really the driver in the last 6 or 7 years for AI. AI has been around. I think the term was coined in the mid-50s by some of those godfathers of computer science. But and even I worked when I did my PhD. I was working on formal verification and automated theorem provers, which are still considered AI today, about automated reasoning and problem solving. But really what we're seeing now in this wave of AI that's really growing dramatically is around this deep learning, particularly using artificial neural networks and machine learning. Now, what it's doing, machine learning, what it's doing is we provide it lots of data and examples, and then the machine can actually learn the rules. So instead of us traditionally as programmers writing the rules about, okay, if we wanted to drive an automated vehicle, we might put in rules like don't go over the speed limit, take the bend at a certain speed and things like that. And we can write those rules. But if we really want to build an automated vehicle, we'd probably have to define, okay, we don't want to crash into a pedestrian. What does a pedestrian look like? What's the rules around defining what a pedestrian looks like?
Sure.
And really, we can't write those sort of programs from rules and from scratch like we traditionally do, right? But now there's this new technology where we can actually show it lots of examples. And if we label, here's the examples where there are pedestrians and where they are, then those algorithms will learn its own rules about how it determines whether that's pedestrian.
So rather than setting hard and fast rules around decisions that are made, you can learn from data that you've collected and train it to make those decisions or certain decisions.
Exactly, yeah.
Okay.
So it's learning those statistical correlations in the data about when the data looks like this and it's labeled as pedestrian. It's learning some of those correlations between the data and the outcome. It's quite fascinating once you look at these algorithms. It's fascinating that the technology works. It's sort of like magic, but actually there's been a lot of smart people that have put the work into these tools in the back end to make them work and to refine the algorithms that it can actually learn this information. And that took a long time, but also at the same time, again, artificial neural networks were around in the 80s and 90s, but they didn't really scale. And part of that scaling problem was twofold. One is we didn't have enough data and examples. We only had a few examples, but now we've had that growth of big data and IoT. So we're in a world where we are not short of data.
Sure. Yep.
But the other side of it as well is it took a lot of computation power. Pardon me. So we had access to cloud computing resources, and also out of the gaming community came these GPU devices which allow us to do many multiplications in parallel, for handling how gaming might fly through a 3D space. But it turned out these processes really worked out for the millions and billions of calculations that the neural network's got to do to infer something from the data as well.
So right, I've never heard that before. That's really interesting. It's one of those cross-technical, innovations, which is amazing.
So yeah, effectively, again, the key point in time was, I think it was 2011 or 2012, and then this new algorithm came out. There was this benchmark test called ImageNet, and it was looking at an image and determining what was in the image. Is it a cat? Is it a dog? Is it a soccer ball and whatnot? So there were these hundreds of thousands of images all trained. And then there was this academic benchmark that people would compete with different algorithms. And finally, the algorithms had sort of plateaued at about like 75, 80% accuracy. And then all of a sudden in 2011 or 2012, I'm not sure of the date, this neural network came out, and all of a sudden it improved it by like 10%, where everything else had plateaued. Basically, we'd reached the maximum of us being able to build these rules and features to where it learnt itself and using artificial neural networks. And then it continued to scale beyond there, where then it's begun within a couple of years to exceed human performance. And that's when the industry woke up going, so we've now got these set of tools that can actually outperform us as humans in doing these certain classes of problems. And then that triggered a whole wave of, investment, which they improved the algorithms. And then if you look at like Google, the number of projects that they deployed from that 2012 point within years sort of exponentially increased to the point where, machine learning's nearly in every one of their major projects in some way. And it wasn't just images, it was then, the same technique we found applied to voice recognition, language translation, sort of spotting sort of sequences and predictive analytics into the future. So all these classes of problems, we achieved this step change in performance. And then being led by the technology companies, we've just seen this explosion of investment and adoption of AI. But we're still to see that come out in other sectors. So other sectors are still early adopters of this technology.
Yeah, and maybe I'd like to dig into that a bit actually. So, you know, you give a few examples, say around, you know, autonomous vehicles. I think, you know, advanced robotics. These are the kinds of, you know, things that I think about when someone's talking about AI. But if, you know, if I'm a small medium enterprise, or, you know, an industry that's been around for a while, if I'm in the energy industry or, you know, the medical industry, how do I use these tools or start using these tools, and, you know, what does it enable?
Yeah, look, yeah, let's start with, there's an area where it's being used a lot already, and is fast getting a lot of adoption, is the computer vision space, about how we analyze either an image or a video. And in the energy and utilities space, there's quite a few companies now that are offering, like, how do we maybe fly a drone along an electricity line and actually do fault inspection. So the
Right.
fact that we can actually train, you know, if we have a camera fly along an electrical line, and we can take samples of that and show them to humans and go, does this look good, or is this a fault? And we do that a number of times, but then we train the computer to do that based, you know, the training derived from the human. Then all of a sudden we can just throw hours, hundreds of hours, thousands of hours of video footage of drones flying along inspection lines, doing quality assurance. So a simple, you know, quality assurance is one of those areas that AI, computer vision, is really taking off. The ability to look at an image and detect anomalies or something that's wrong.
And presumably that could cross into pretty much every industry that you need to, you know,
If
be
you're
able
in
to monitor something.
manufacturing, if you're even in fashion design and food preparation, I think it's Domino's Pizzas have a camera that look at the pizza and sort of say, does that meet our quality level? Is there the right mix of pepperoni and cheese and things like that in the pizza, as a sort of a quality check? Or so, you know, there, you know, really, you know, you can apply this to so many different areas, but then the key is, where does it add value? You know, so yeah, I could go and build an algorithm to do just about anything now with machine learning, but what's actually going to derive value for me? You know, and something like doing an inspection of an electrical line, you know, that's an expensive process for a utilities company. But if that's something they can do really cost effectively and almost do after every storm, you could see that leads to business benefits in terms of increased availability and reliability of their network. So, you know, that's where you try to then look for the business value that you can derive from it.
Yeah, great. So, I guess if like I know, as you said in your introduction, you're quite passionate about Queensland, obviously, but also regional, like the regional part of Queensland and, you know, far north Queensland. I know you've turned your mind in conversations we've had in the past to this particular region, opportunities that may exist. Did you want to talk about that at all, and some areas that you really see some challenges, but also opportunities with AI in the far north Queensland region?
Yeah, definitely. And you gave my extensive resume at the start, but you know, my very first job out of high school was working up in Cape York for the Water
Right.
Resources Commission, and we used to go out and set up measurement recorders on the rivers around Cape York and the Gulf, and travel around. But you know, very familiar in that territory of, you know, we'd have to drive out in a four-wheel drive. We'd go out for 3 weeks in the wet season. We'd fly it in helicopters, and we'd go and collect the data from these recorders and hope some tourists hadn't sawed off our solar panels off the top of our roofs and things like that. But that idea of data collection in these remote areas, you know, is something that I think is opening up big time for us now. You know, the growth of sort of satellite data. I think as we launch these low Earth orbit satellites, not just with the ability to collect more data, but to actually deliver, you know, network coverage, so that what we've got out there running and sensing and things like that, we can collect and communicate back. And I think it's, so as I said, big data has been one of the big drivers of AI. We're moving into this world, particularly in northern Queensland, where, you know, very vast regional, you know, natural resources and environment and things like that, where we can collect a vast amount of data and AI gives us the power to actually derive value from that data. And I think that's the challenge now, is to think about, for North Queensland, what is that value we can derive that's unique about the far North Queensland or the Northern Australian region. That's different to here in Southeast Queensland and things like that. And I think a lot of those things are, in my head, the areas that are going to be key. And I think, Keith, you and I have chatted a bit about this, is, I came from a defence sector, and Northern Australia is critical to defence. We've got the Great Barrier Reef and the Torres Strait, these incredibly valuable, unique, globally important sort of ecosystems that need to be managed, not just for North Queensland or the Queensland government, but, for the world effectively. How can we more effectively sort of assess and manage those sort of, those natural resources? We've obviously got the agriculture and mining industry that's working in those environments, but we've also got our remote communities and our Indigenous communities. And I think it's even hard for a person like me that's not from that community, but I can just imagine some of the opportunities that people in those communities might create that they see as unique and can deliver to the world, whether it's around sort of cultural sensitivity or education, or how we share information about biodiversity and other aspects. So I think, I think we've got a lot of things in the north that are very unique in the world and very strategic to many of the world's opportunities and challenges. The key is, how do we work together to think about how do we leverage the value that we can drive from that, and what's the underlying infrastructure that we need to get in place so that we can give access to the communities up there to build those next generation AI innovations.
And what do you think that infrastructure looks like?
Yeah, I'm a big one for both sensing devices. So whether that's IoT or whatever you want to, somehow you've got to capture the data. And I think there's going to be a big element of that is the network. What's the mesh? What's the network that we connect devices? We also need to think about how we power devices. What sort of power supplies are there? Do we need to rely on low power utilization, but relying on solar and other aspects to power sensing devices? I think, the network to then transport the data, but then we've got to think about the infrastructure, which is actually collecting the data and storing the data and helping to then build platforms that others can analyze it without having to build everything from scratch. So I'm working in the medical space with Queensland Health a lot around creating this utility for data sharing. So we're collecting data from intensive care units, the bedside monitors. We're sort of cleaning that data, getting it ready, but we're not doing the end research. It's about how do we provide that utility and that infrastructure so it's easier for other researchers or other entrepreneurs and other groups to make use of it and then do the value add bit at the end. Yeah.
Right. So you're kind of like a data enabler rather than doing the specific research yourself or the use cases yourself.
That's right, because I think there's a lot of power in being that sort of utility function. Because what you typically find is a lot of people come in and they try to do this vertical end to end and trying to own the entire ecosystem. But you go into these ecosystems, they're massive, right? In the healthcare area, how to integrate across the different medical systems that are within Queensland Health and the amount of data that's collected. There's no one person that can really own that and deliver the best value in every possible area. You've really got to think about the ecosystem. And I think it's the same in, say in our natural resources sensing and so on as well. And I think we also have to think about how do we collaborate with government in sharing that data as well? Because I really see this as a national asset, right? And I think probably moving into this next economic phase, with COVID having the economic impact, is, I really want to see government invest in some of this future infrastructure that enables this next generation of businesses as we come out of this post-COVID economic slump, which I think we're unfortunately going to have a few tight years in front of us. But I think these are, I don't want government to just think about putting in roads and railways. I want them to think about putting in some of this future digital infrastructure that's going to benefit our companies, our universities, our entrepreneurs and startups and so on, and help to attract other businesses also to come to Queensland and invest in Queensland as well.
Yeah, absolutely. I guess a question, that grows out of that is, we're seeing this challenge that we're having economically at the moment. And we talked a bit about physical infrastructure there. I wonder if I can get your thoughts on human infrastructure that's required to roll out this kind of technology, and what the scope of that human infrastructure is.
Yeah. Look, I think there's going to be a big skills requirement to get this to work. Again, this is very much an early adopters phase we're in at the moment. It's sort of like that 10 to 20% of organisations have even probably contemplated what this really looks like. So the skills have first of all got to start with those leaders, the executives, to actually see what the possible is. They need to understand enough about the technology, not just for driving the technology, but so they can actually recast what their problem is and then how they might solve it. Because I think if people don't really understand what some of this new AI technology can do, they don't even think about the problem they can solve with it, right? Once they know enough, then we need to think about the problems worth solving and trying to get our leaders to that point. Everyone thinks, yeah, we need more data scientists and things like that, but there's a lot of work going on to actually make the data science even easier. And in some ways, the first group to be maybe automated out of by AI is actually the AI engineers who are rapidly automating a lot of the work that they do. Because I think at the end of the day, what we find in teams is very much multidisciplinary. Working in healthcare, we need data scientists, but we need those clinical people. We need the nurses, the doctors. And because what we find is there's a lot of work to sort of pull out the data, but you've got to understand the data and you've got to understand the decision and the business workflow that it sits into. And then we're going to need people who can label the data or validate the decisions and things like that. There's a whole sort of career around data labeling, and not just, you don't want to be sort of put into I don't know if you've heard of Mechanical Turk, who's like Amazon's, they got like a worldwide army of people that can label data. So like a autonomous driving company, they will hand over all these videos and get someone to label and draw out the cars and the trucks and the pedestrians and the traffic lights, and is it a red light or a green light, and everything effectively gets labeled. And it can be an extremely time-consuming process. And you could imagine if you were doing this day in, day out, it'd be like working in a call center, right?
It'd be mind-numbing.
Yeah, but on the flip side, what we're finding is it's around how those people really work in a smart way. How do you design the labeling structure and work alongside the automation to collect and label that data in a really intelligent way? What's the important data to collect now? I often say, once I've got 1,000 kilometers of straight road for my autonomous vehicle, I don't want more straight road, but that's probably the majority of it. Now I need bendy. So how do I go out and find data that's unique and then sort of label it and use the different tools I've got to do that? There's going to be this whole class of employment around, creating and curating data sets for machine learning. And then I'd expect as automation rolls out, there's also going to be that class of skills where people working on a mine site or people working for the local government actually thinking about the infrastructure that's out there and how do I keep that in place, whether it's having good road markings on road edges or other things around a mine site, because they're aids to help the automation work better, right? So it's sort of that understanding. I often use the example of, what's this new career of a diesel fitter going to look like on a mine site when we've got autonomous mining vehicles? Do they really need to understand the sensing and the data and how that system's working? I think they do. Similarly, if you're a national parks officer up in Lakefield National Park or something like that, what's the sensing data and the monitoring data and the AI that you're using to provide better park management? So these people that you wouldn't think of technology jobs, I think will move and require some education about how AI and technology is going to fit into that workplace.
Yeah, right. And I guess it kind of, speaking about these jobs like data classification, for argument's sake, it also builds a vocational pathway, essentially. It's, if you're an apprentice builder, you're not going to build a house straight away. You start at the base skills and work up from that, but it develops this whole pipeline of employment potentially in these trades.
Yeah, well, people don't realize, but one of the biggest companies that does that data labeling job is an Australian company called Appen. They're worth $1.5 billion on the Australian Stock Exchange. Probably the majority of Australians have never heard of them. They acquired one of the companies out of Silicon Valley that do a lot of the labeling for autonomous vehicles and the retail industry, like labeling sofas and clothing and stuff like that. And they acquired them for $400 million. People don't realize these companies are out there that are employing and are becoming sort of massive organisation. That one's an Australian company, one of the biggest in the world, right?
Yeah, right.
Fascinating. Yeah, Appen, their name is. Yeah.
Okay, I'll look them up. You were saying before about business leaders like at the C level, for argument's sake, or I guess even small medium enterprise, the people really running the direction of the business or the enterprise. How you were talking about opening their minds up to the opportunities that are available for this technology. If I was sitting as a board member or a CEO of one of these companies and I wanted to explore it, what's the best way to engage with that? How do I go about doing that in the current environment?
Yeah, look, that's something we've been giving a lot of thought to. How do we start that education process? Because I think that's the key to innovation and investment. I'm not 100% sure, to be quite frank. I've got a few ideas, and I think one is, I think that first of all, I guess the first thing is, are they curious? And I think probably the curiosity will be driven by, do we need to highlight to them, not only the opportunity of AI for their business, but perhaps the threat of AI for their business. And, people worry about Terminator robots and when's AI going to become smarter than a human. That's not the challenge, right, for our businesses. The businesses are this change in the workplace and the change in the competitiveness from productivity perspective. There's billions of dollars of investment from governments overseas in this space into their industries. And if our businesses aren't globally competitive, we will lose market share, right? So I think what we've got to look at is how do we really educate our businesses, not only to create these global opportunities, but also to protect themselves to be globally competitive in this future world where automation will improve productivity. So I think that's the first thing we've got to do is create that motivation, why they need to do this. The second aspect, I guess, is how do we create a forum that they'll actually show up to and engage in? And I think part of that is you almost have to collect people together. I think you get CEOs of larger companies. They love to come to an event where there's other CEOs of larger companies that they can talk to and share ideas. So those sort of contexts of giving people not only an education session, but connecting them with their peers so that they can sort of compare notes and collaborate. But the other aspect, I think, if you've got to vertically align it. It's almost impossible if I take someone from medicine and then they go and talk to a farmer, right?
Okay.
Probably at the underlying level, there's a lot of commonality in the way the technology is going to be applied. But the way it's solving the business problem it's hard to translate it for them from one industry to another because the industry and the drivers and things like that are so different. They just think, how is this relevant to me? But in the same way that we might use AI to predict, what the future trajectory of a patient might look like, I'd expect a farmer might want to look at some microclimate sensing around their farm to understand, well, what's the weather going to be like maybe tomorrow for my farm and its microclimate because I want to spray pesticide or something like that. So underlying, some of the technologies are common, but they find it really hard to translate that problem value to from one to the other. So we've got to create these forums of how we get these groups together around certain classes of problems in different areas, and the way the technology delivers value in that area.
Do you think there's almost an opportunity there in the market at the moment to be a person that actively, or be a company that actively goes out, looks at what data people have and demonstrates to them the ways that these tools can be used? Do you think it needs to be that, aggressive rather than more passive?
Yeah, there definitely is, but that's costly too, right? To go out and do that education. And I guess that's some area where, again, coming back to the Queensland AI Hub, having some government support for those sort of educational elements and early research and development, because there is a lot of risk. You take a startup or a research and development project, there's that investment risk, right, of being that early leader. You're exploring, you're having to customize and develop some tools because it's earlier in the adoption life cycle in that area. So, if you look at the adoption life cycle, you have these, early adopters, and then the sort of late majority, and then you've got your laggards and things like that. So I think there's going to be these different personalities in the community that take on these roles. You're going to have your super early adopters, and you have them there already in Cairns in AI, and they're probably going to be key to the rest of the community coming on board. These are your explorers and the ones that are out there breaking ground for the rest of us. And probably for them, the spoils might come for the ones that are maybe slightly behind that, but really standing on the shoulders of the others. So yeah, I think, but at the same time, I think when you look at innovation and who does innovation, a lot of times the innovation is driven by the entrepreneurs and the SMEs and the startups, the spin outs from university projects and things like that commercialize, because it's very hard for a large corporate or a government department to do this, right? The risk is high. You're making lots of bets. Some of them will pay off and some of them will pay off big time. That's why, sort of startup funding and VC funding exists. It's high risk, but it can be high reward. But it's typically going to be that part of your community that are going to lead the way. And equally, you go into small businesses like farmers and small mines and things like that, is oftentimes you do have that innovator in that, inventor in that company, and that's sort of what's driven them. And if they're super successful, what you end up finding is they get acquired by the big company, they get absorbed later on, because it's very hard for a large organization to have the culture to do that.
Be nimble enough to do it. Yeah.
Yeah, exactly. Being nimble, agile. Yep. You've got to adapt, to the circumstance. So, about 6 years ago, I started on an AI startup in the travel industry. And I think what we built out from a technology point of view using AI, where we're personalizing itineraries, and it was scheduling the itinerary and matching up depending on what you'd chosen, how it would work. And I think the technology sort of worked, but we couldn't crack the business model, in terms of getting people to buy it. The travel industry is a really hard consumer market to break into. So then we pivoted and tried different models. But at the end of the day, I think we failed, not because of the technology, but more because of trying to find the right value proposition, the business sustainability of it.
Which is largely how it goes with startups, I think.
Yeah.
It's rarely the product that's the problem.
Yeah. And, at the end of the day, it's that sort of Darwinian evolution, right? If we cracked it, we'd probably still be going really well. But that's not being said there's not value in that process. We then finally gave up on that idea. I've moved back into sort of the medical space. One of my other co-founders, he went on to another venture that raised $2 million in capital around a smart cricket ball, working with the Australian cricket team and Kookaburra, where, all the data we collect off the ball now, every time someone bowls the ball, they'll know speed, spin, and how hard it was hit and where it went and things like that, right?
So
Yeah,
he's
so
behind all of those analytics we get on our TV when we're watching.
yeah. I think they were planning on some stuff for the Big Bash League or something like that, where it'd have, basically every ball getting logged.
That's cool.
Yeah, really cool. And so, I think for entrepreneurs, it's, it's not really failure. You've explored, you pivoted, it didn't work. That venture might have failed, but the skills that were learned, hopefully they're hard-learned skills that help you succeed the second or third time around.
How are we going in this space as a nation? Like you were saying before, there's one of the key risks you see is that our industry gets left behind to a degree on this in relation to other nations. How does it stand at the moment?
Yeah, look, I think there's a couple of aspects. One, if we think about that sort of startup and innovation space, Australia has developed a lot, and like the Queensland government has put a lot of investment behind this in the last 5 years with different programs, and we've definitely seen benefits of that. But Australia is still sort of challenged in accessing that later stage capital that you would have if you're in the US in terms of venture capital funding.
Sure.
It's definitely improved a lot, but still probably if you're a startup at that phase, at some stage getting to those bigger rounds of funding, you would need to go offshore to seek that investment. But on so that's sort of the startup phase. That I still think Australia's got a very healthy R&D sort of culture here. We're the beneficiary of a great education system. So we tend to have world-class engineers and things like that. And I know many companies that have, say the sales and marketing might be done in the US or something like that, but they've retained the engineering team very much in Australia. But I definitely like to see, the business drive commercially more out of Australia. But, we are a smaller market, but I think for entrepreneurs, we've got to think about ourselves as a part of a global market. So there's that side. On the AI side, we're definitely lagging in terms of investment. I was in, we do a little bit of work with MIT and I was over at Boston visiting them. And the week I was there, they announced a $1 billion AI center to be opened at MIT with $300 million investment. These are US dollars, by the way, not Australian pesos. It's and I think $300 million in cash from BlackRock, which is one of the big private equity firms over there. We've seen similar sort of. I think Trump just announced over $1 billion sort of investment in AI research coordination just recently. The Chinese government really backed this. They describe in China the AlphaGo, when AlphaGo won the Go competition. Mm-hmm. They called that their Sputnik moment, a bit like when Sputnik was launched and then it catapulted the US into the space race.
Can you explain AlphaGo, just for listeners who might not be familiar with it?
So Go is this ancient Chinese board game of moving pieces. The rules are quite simple, but the size of the board means that the combinations are huge. So we had Deep Blue won chess 20-something years ago, but literally 5, 6, 7 years ago, they thought it would still take another 20 years of technology before we could deal with the computational complexity of Go. But right. Then this company called DeepMind. And again, this is a fascinating story. DeepMind got created by some smart people out of the UK. And the first thing they solved was they used AI to compete in all those classic Atari games. Like bouncing the ball, breakout and stuff like that.
Pong and...
So they worked out an algorithm using deep learning that could actually play any of those games and exceed human performance. And they never sold $1 a product, and they got acquired by Google for $400 million.
It's mad.
But they took those same algorithms and applied it to Go, right?
Yeah.
And then they developed this they beat the world champion in Go, right? And that was the Sputnik moment for the Chinese government, because Go's like embedded in their national culture, right? And it's, holy crap, the AI has beaten humans in doing this. What does that mean for other things? And so Google acquired this company, and they apply those same techniques to healthcare. They applied it to running the cooling and power control within their data centers, and they reduced like their energy consumption by like 25%, which reduces also, carbon production and things like that. Just through these algorithms, that reinforcement learning and other things that optimize what the right choice is at a particular moment in time. So,
so they're like they're meta algorithms essentially that you can apply across different dimensions and different sectors.
That's right. So in machine learning, there's various algorithms that you might sort of choose to apply to a particular kind of problem. So if I was just doing something on, say, some spreadsheet data with tabular data, and I didn't have a lot of data, I'd probably use something like random forest or a decision tree, because it'll learn quickly, fast, with not a lot of data. But if I want to use artificial neural networks, I sort of typically need a lot of data, but it's even getting better there with another sort of technique called transfer learning, where we train it on another data set elsewhere, and then we can sort of calibrate it locally to our data set. But then there's these other techniques like in deep learning, what's used in imaging is what they call convolutional neural nets, which sort of are modeled on the way our brain works for its optical processing. So, so basically it's creating these convolutions, which are like little filters that look for like edges or textures in the image. And it learns these themselves by applying these masks across the images, and it trains them themselves. And that convolutional neural nets is that sort of class of algorithms. And then we've got like reinforcement learning, and then there's like transformer networks now, which use attention, which is used on language processing. So kind of what you've got to do is, when you look at the problem, you try to think about, well, what's the technique you might apply? And really your first attempt should be maybe starting with the simplest technique you can, because everyone gets excited about, I want to go and use reinforcement learning at AlphaGo use, but yeah, there's a lot of fine tuning required, and parameterization to actually get it starting to work requires a lot of expertise. So maybe starting with something easier first, but then that choice of technique becomes important. But what we're finding now is the big companies like Google and Microsoft and Amazon are now trying to provide what they call auto ML. So when you give it all your data, it's trying to use an algorithm to help it pick the algorithm to use. So it's trying to automate the machine learning process, what the network should look like and so on.
Oh, and that's really interesting. So do you see something similar to the no code kind of revolution? For those that aren't familiar with no code, there's a piece of development or a development pathway that happened over the last few years, where rather than paying a developer to code all of your software, you can pretty much just go onto a site and drag and drop and create a website yourself. So do you see something similar down the track for machine learning, AI, and data science?
Yeah, I definitely do. I do, and in fact, I know there's a lot of effort to, I'm a computer scientist almost. I'd like to think from birth, but I know computers weren't that advanced when I was born. But I've loved the career of computer science and programming, but we're starting to teach all kids at primary school now, coding and things like that, where I kind of think really what we want to do is teach people data skills and how to really, because I think the key of the future is how we're going to work with data, how we collect data, how we process it. And it's not so much learning to program in Python or stuff, Python, whatever programming language. We're going to need some people that have that skill. But, if we have a team of 10, I might say we'll have one data scientist or one AI engineer, and then there's 8 other people. You need your marketing salesperson, you need a person who understands the business problem. And but then there's a lot of data, what I call a technical word, data munging. How do I collect my data? How do I look at it? How do I look at the decision the algorithm's making and validate what's going on? And a lot of those skills aren't programming. Once you've got a person on your team that's got some good analytical skills, and it might be just pointing them to, here's a notebook where they can add a few other query strings on the end of an SQL statement or something like that. You know, they don't need to be writing API code in Python and stuff like that. So I think, you know, when we think about the entire team, there's a real mixture of skills, and it's probably a lot more the analytical sort of data skills that will become more critical.
Yeah, sure. And I guess I'm picturing in my head, and I don't know how far we are away from this, but if I'm if I'm in a startup, for argument's sake, and I have a bit of a creative bent, I can do the marketing until I scale to a point where I, get in a proper marketer. Do you see that happening, in the short to medium term in this kind of data science space, where I can do enough until I have to employ a professional?
Yeah, look, I think, at the moment, the way the technology is, you still will need a technology person that you have access to. And that's the choice is, can I outsource that to somebody who sits in the Philippines or something like that? It's hard to manage that person at distance. And it's all, we say often when, you have that joke around startups, and it's the same for an AI startup, you sort of want your hacker, your hustler, and your hipster.
Yeah.
Is what they, and in health we say hacker, hustler, and healer, right? So having a doctor, a technology person, and a business person, and it's rare that you're going to have one person really has all those skills. They might overlap a little bit, but you want some depth in those areas, because one thing you will have to do, I think, is have access to a person that can help you to deal with lots of data that you're going to collect and how you process that data.
Okay, great. Well, I guess growing out of that, I had one more thing that I was asked before I came into this session to raise, and that was, if I'm a budding young data scientist who's doing their course in university at the moment, what are your pieces of advice to develop and grow my career?
Well, if I was a student at the moment, I'd be looking to embed myself into a project where I go and find that hipster and a hustler that have got a problem to solve, right? And help them solve it. Because, joining up forces with other people is going to be key to rapidly develop your skills, whether you can go and do that within a startup environment where you sort of volunteer your time as a bit of a co-founder, or do you place yourself within an existing project with an existing team just to learn from that and potentially add value? I think if you go into a startup environment or an R&D environment, you'll have to learn a bit of everything. So you'll learn a lot of skill sets quickly. I think if you go into a big organization, you'll get pigeonholed very quickly down to a niche, and you probably won't learn as much as quickly. Yeah, but startups rarely have money, so do you treat it as a bit of a sweat equity thing or a learning environment and things like that? But I tell you what, you'll learn a lot quickly through working with some of these organisations. I mean, it's very tempting for everybody to have their own problem. They get very entrenched in their own problem. So you might have a young grad go, "Oh, I've got this solution. I just need to go and find the problem for it." And they get very wedded to the solution, but then you've got to then convince a couple of other people to be co-founders with you, and that's not easy, right? So it's about getting on board with other people, and I think showing up to some of those events like hackathons and datathons to find collaborators is really key. But I think the key for a young graduate is to get out there and start dealing also with some realistic size data sets, because again, some people would, just get on to Kaggle and learn on Kaggle. But Kaggle's not the real world. You're talking about pristine data sets where everything's labeled. All now I need to do is to point my machine learning model to it, and hey presto, it pops out. But the reality is you'll be doing 80% of your time trying to just collect your data and get it into a shape and try to clean it up so you can play with these models, and that'll be most of where your work is. So collecting data is a big thing, and who do you work with to collect that data? Because that data might not be available yet, and you might need to work with a partner. Like we had one team wanting to analyze food that's being served in hospitals to measure how much consumption there's been on the food tray, so taking a photo before and a photo after. So your initial
that's
thing
interesting.
No, really cool. especially from because malnutrition is a big problem in a hospital, right? That a lot of people don't eat while they stay in hospital, and they actually get sick because of malnutrition.
Right.
So if you could actually measure what people are actually consuming and what the energy consumption and how it meets your dietary needs, that's a really critical thing. But the first thing that team had to do was go and collect the data, right? Set up cameras and go and start collecting it. Then they had to label it and stuff like that. So yeah, you've got to keep that in mind. But you know, what I loved about computer science is, you know, I love the technology, but I love working in different business areas about how do I solve some of these really hairy, important business problems. And yeah, so working with business people that have got a passion to solve a problem, I think there's nothing more fun than that as a technology person, to work with inspired people like that.
And beyond going to a hackathon or a datathon, is there a way, like, how do you find those people? Do you actively, you know, pursue them, run them down in the street? And
No, we obviously work with our local universities here quite a bit, and that's very. I think we're in a world now with COVID where you could almost work anywhere, right? And we've got the collaboration tools, but we work a lot with the universities with you know, student interns, work integrated learning projects and things like that. And we find that really powerful. You know, probably in half of the situations, it ends up creating either a job offer from us or a job offer from someone we know that we can refer them to. But we get a lot out of that project in terms of both, you know, we don't try to go into the project, we're trying to build a particular product out of it, but jointly we're going and exploring a new problem area and what can we learn both for the student as an education thing, but as well for us about what have we learned through that process about what the data looks like or understanding the problem better and things like that. But that's a great mechanism. And the unis, like, you know, again, not trying to put any particular uni on the spot, but you sort of rely on the bureaucracy. It's probably not always the best for, you know, you might get the one student referred or the second student referred, but then you chat to those students, hey, if you got any mates that are interested in collaborating, next minute, you know, there's a gaggle of students that are interested in the problem show up. But you know, we find that a really good process of sort of creating that engagement. You know, so that sort of process, you know, of trying to connect the industry in with the university to give those education opportunities for the students are quite key. And that's beyond, like you said, the events like the hackathon or the datathon. Yeah, so I think we really seek out as a partner to have a good relationship with the universities and with the academic staff in particular, because they're often the ones chatting to the students. Hey, I know this company, you should maybe give them a call and they're doing some really cool stuff that you might like, sort of thing.
Okay, amazing. Well, look, unfortunately, my time is flashing on me here, so we might have to wrap things up here. This hour's gone incredibly quickly. Look, it's been an absolute pleasure, Kelvin. Do you have any final words for the folks of for far North Queensland and beyond?
Look, I think there's some really amazing global opportunities for FNQ and Northern Australia. I'll be up your way in end of November and December, and definitely been chatting to Keith. I'll be paying a visit and stuff like that. So hopefully get to meet some of you in person. But certainly the work we're doing across Queensland, you know, this distance is not a barrier to us collaborating now. So yeah, I'd love anyone wants to contact me and how I can help you out or collaborate. You know, I really get a kick out of helping people out on that front. So yeah, and like I said right at the start, you know, far North Queensland, you know, the Atherton Tablelands and Cape York is still one of my fondest places in the world. So any opportunity that I've got to get back up there, I'm there.
Well, you know, we'll make that happen. So yeah, as you said, at the end of the year, we'll make sure we get you up here to the Ideas Lab, show you around, and maybe do a spot of diving while you're up here as well.
Yeah.
Well, look, thanks, Kelvin. Thanks so much for your time. I know you've got so much on your plate at the moment with the Queensland AI Hub, as well as the bunch of other things that you do as well. So we really appreciate taking an hour out of your time to spend it with us. Thanks everyone else for joining us. Look, the JCU Ideas Lab is now open. So if you'd like to, come in and have a look around, please feel more than welcome to do so. If you'd also like to keep posted on our future programming activities, jump onto the site link that Louise popped into the chat before. Pop your details in the registration page, and we can keep you informed in what's going on, including activities that we're doing in conjunction with the Queensland AI Hub. We'll be posting this video on our socials and on our newsletter as well. We'll make sure, if it's okay with you, Kelvin, to drop some contact details to you in case everyone wants to get involved.
Definitely, yep.
Excellent. So look, thanks very much for joining us once again, and hopefully see you all again next month. But until now, I hope the rest of your week is excellent, and goodbye from the Ideas Lab.
Thank you. Take care.